All right. Hi, everyone. So today I'm going to do Codeforces around 695. And before that, before you skip, there are three main announcements. So first of all, join my Discord server. So we do lots of stuff there, like suggestions, problem discussions, and a lot of memes and animal gifs. So that's one. And secondly, the second announcement is that if you are interested in Hindi content, then you should go to the community tab of my channel or go to the post by clicking on the link in the description. So I'm gonna do a kind of series of lectures in Hindi on some topic. So you have to decide the topic by voting in the poll, and the lectures will be on an academy. So, but they'll be free for all, so you won't have to be paying anything. Apart from that, we hit 5,000 subscribers on our channel. So I'll be doing a video on how to set up Sublime Text like me. So yeah, those are the three announcements. Okay, now you can skip ahead if you want. So we're at problem A right now, Wizard of Oz. Okay, I like this contest already, Wizard of Oz. Okay, so there are n digital panels placed in a straight line. Okay, so each panel can show any digit from 0 to 9. Okay, so initially all of them show 0, and okay, each second. mm, okay, okay, so it's kind of increasing each second. Okay, so if you pause one of the panels, then does that change? Okay, so we have to pause exactly one of them. Okay, then the panels that are adjacent to it will get paused 1 second later. Okay, so one by one, it's like an infection that will spread. Okay, so we want to get the largest possible number, right? I think to get the largest possible number, it's always optimal to get the first digit as 9. Okay, so like the first digit is always 9, but what can we do with the rest of the digits, right? Wait, what is n? N is n the number of digits? Hmm. Okay, so initially all are 0, and okay, yeah, n is the number of digits. Okay, so okay, from left to right. So yeah, it's kind of obvious that we want the first digit to be 9. Okay, then I think we want the second digit to be 8, I guess. So the third becomes um yeah, the third one is 7 and 6 5. So like 9 8 7 6 5 kind of thing we want. Or can we get something better? Mm, I think it's like there's nothing better than making the first digit 9, and then the second digit can only be either 8 or 0. So it's definitely better to make it 8. Then the next one can be, I think the next one can be 7 or 9. Okay, so I think it's always better to make the next one 9, right? So do we always stop the second one when it becomes 8? Like whenever it becomes 8, we make the second panel pause. We pause the second panel. So it pauses on 8, and then the first and the third panels become 9. Okay, so I think greedily speaking, that's the best choice that we can make. I don't see anything that can be better. Yeah, because otherwise, if we do anything else, we'll have 987, which is worse. Hmm. Yeah, so I think that's what we want to do. Okay, so it will be like 989, and after that 0 1 2 3 4 5 6 7 and so on. Okay, so take in n, and don't forget test cases. Okay, so so if if n is 1, then just print 9 and return. Okay, otherwise we just print 9 and 8. Okay, and then for the remaining digits, the rest of the n minus 2 digits, we can just keep printing I mod 9, I think. I mod 9. Okay, and then we print a new line. I think this should work. Okay, so this is 9 and 9 8. What if we had something big like 8-digit number? Okay, wait. Okay, sorry. Okay, yeah, this is wrong. So we need another condition. If n is 2, then we just print 9 8 and return. Okay. Otherwise, we print a 9 8 9, and n minus 3 characters are from 0 to whatever, like we'll count. Yeah, okay. So this is the best possible answer that we can get. And to do this, we just pause this one when it's on 8. So these two become 9, and like this is the best answer because like we compare them greedily. Okay, so 6 minutes. So yeah, that was a bit long, but anyway. By the way, if you oh no, this is wrong. Okay, so okay, so this is wrong. I think you wanted to get the largest number, right? Hmm. I think 989 was the best thing to do. I think. Like what can be the like first three digits better than this? Because the first digit is definitely 9, so there's no confusion about that. The second digit should be 8 because they should differ by 1, right? Like they cannot be same. Any two adjacent digits cannot be same because no matter where you pause, like the consecutive digits pause at 1 second later. So it is impossible to kind of wait a minute. Hmm. 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 I think I interpreted the question wrong, maybe. So suppose there are 4 panels and the third panel is paused when the digit 9 is on it. Oh, okay. Yeah, so when we pause this with a 9, then both of these are 0 and this is a 1. So yeah, so this is correct. Once all panels have been paused, you write the digit displayed on them from left to right. Form an n-digit number can consist of leading zeros. What is the largest possible number you can get? So okay, okay. So what I thought here was like if we had a large number, okay. So the best possible digit that we can get here is definitely 9. and this cannot be 9 because like two consecutive digits can never be same because they paused at difference of 1 second. So this can either be 0 or 8, and there's no other option here. So I can see that 8 is definitely better here. So let's put 8 here. Okay. If we put 8 here, then this can either be 7 or 9. I know that 9 is the better option because like 9 is greater than 7. So I like kind of I would want to put 9 here, right? So any optimal number, like any optimal answer should begin with 989, and it is actually possible to get 989 by waiting for 8 seconds, then stopping this one. What will happen is it will stop at 8, then both of these will stop at 9. So it is possible to achieve this answer. Okay. So if we actually do this, what will happen is this is 8, 9, 8, 9, then this will be like 0, 1, 2, 3, and so on. Okay, till okay, so I think it should okay. I got my mistake. So this should be mod 10 actually. Okay, okay. So that was a silly mistake that costed us a lot of time. Okay, okay. I think this might be my slowest A submission. Okay, okay, no worries. We'll cover it up. So you are given a sequence of n integers. Problem B, hills and valleys. You are given a sequence of n integers a to a1 to an. Okay, so we call an index a hill if it is greater than both elements on the left and right, and it should not be on the extreme points. Okay, and we call it a valley if it is smaller than both of them. So let's define it. The intimidation value of a sequence is the sum of the number of hills and the number of valleys in the sequence. Okay, so okay, so we have some intimidation value for the sequence. It is the number of hills plus the number of valleys. We can change exactly one integer in the sequence to any number that we want, or let the sequence remain unchanged. So what is the minimum intimidation value that we can achieve? Okay, so okay, let's try to examine this one. Yes, so we have like a sequence, right? Again, so one element can be a part of a hill. Sorry, one element can be a part of a hill, and I think it can also be a part of a valley and another valley here. Okay, so one element can actually be a part of I think one hill and two valleys, or maybe two hills and one valleys in this case. Could be a part of two hills and one valley. Okay, something like this. So yeah, that's the amount of that's the maximum an element can do. So it can be at most a part of three. Okay, so that's the most it can do. Or maybe it can be a part of no hills, no valleys, or like two hills, two valleys, or anything. So yeah, so that's what's happening. Um, by changing an element, we can decrease the answer by at most three. We can either not decrease the answer at all, or decrease it by one, by two, or by three. So that's what we can do. So I think if we find any point where we can by changing that, if we can decrease the answer by three, then that's our answer, and we will want to do that. So how will it even work? How will we decrease the answer by 3? I think it is only possible if these two are equal, like this is equal to this, and then if we make this one also equal to that, then I think that's the only way to get them full. Or maybe I'm wrong. Let me see. Okay, so if like we had a valley, then a hill, and then a deeper valley, can we just change this element to remove all of these at once? Okay, so we go here and like we should go even below. We go somewhere here. Like if we go up, then there's no point. And even if we go at the same level, then there's no point. Okay. From here also, maybe we can just go flat because if we go down, then the problem will be this will become a new valley. We don't want to form a new valley. So maybe we can go flat like this and we can go down like this and reach this point here. Okay, so if we had any kind of uh, like, uh, two valleys and a hill, if we had something like this, what we could do is we could take the deeper hill, go flat like this, and intersect this here kind of, and bring this point here. What will happen is now this is not a valley because like these are all three are decreasing. This is not a valley because like this is not smaller than both of them, and this is not a hill because it's not greater, and it's not a valley because this is equal to that. Okay, so if we ever find three elements equal, sorry, if we ever find any point that is affecting three, adding three to the answer, we can just subtract it, and doesn't matter how greater or smaller it is. So that's something we can do. Apart from that, what are the cases of two? I think the cases of two are when a single element is a part of a hill and a valley both. So what can we do in that case? I think just by making these two equal, we're done, right? Mm, I don't think it can go bad. Like, wait a minute, can this go bad? We have something like this, okay? Here we are forming a hill, here we are forming a valley. Let's say we want to change this one. So can we change it without making another valley or hill or anything? Okay, so hmm, we know that this is not forming a hill, otherwise it would have been 3. So either this is equal or greater than this. So if this is smaller than this thing, then we can just come up till here and this won't form a valley. Okay, but what if this is greater? Then if we go up till here, this can form a new valley, which is a problem. We can do that. Let's consider the case when this is greater than that. What do we do in such a situation? Okay, so if we try to take this one here, mm, well, like, okay, so delete this hill. Like, we cannot delete the hill by tempering this because the problem is okay, so we know that this is not a hill, right? So this could be something like this. And if we go above this line, then this will form a new valley. So it is useless. But if we stay below this line, then this is still a hill. So there's no point changing this. We have to change this now. And I think things are similar here. Like we must reach up, like we must reach till this point or deeper, because if we come down only till here, then it is still a valley, so it's pointless. We have to come down at least till here, and we know that this wasn't a valley. That means it must have been something like this. Okay, we have to make sure we don't make this a hill. So if we join it like this and we go deeper than that, then this becomes a hill. Yeah, so this is problematic. If it is a part of two, then it's problematic. But let's see if it is just a part of a single one. So let's see what will we do in that condition. Okay, so this is a hill. Let's say a hill. Even if it's a valley, then it's the same thing. Okay. So we know that this is like this and this is like this, because we know that this is not a valley. We know that this is not a valley, so definitely has to go down, both of them. Then what can we do with this one? Mm, okay, so depending upon these two, whichever one is greater, let's say this is greater, we can just take this till here. So this is not a hill anymore because it's now a plateau and no valleys are formed. So one can always be decreased to zero, three can always be decreased to zero, but there's an issue with two. So let's see the case of three again. So when it's three, we have something like this. We have two valleys in one hill at the same time. What we do is we take the two valleys, take the deeper one. So let's say one is deeper than the other. What we will do is we will just take this down and level it with the deeper one. So we will be having something like this. So it has no valleys, no hills, nothing. So we can decrease the answer by 3. Even in the case of 1, it is easy because what we can do is like our case is something like this. So we pick the higher one and just join it here. So again we get a kind of plateau, I think, and no hills and no valleys. Okay. So the only problem is when we have kind of like two elements starting from the same point, like a hill and a valley at the same point. This can be a hill at this point, and this element can also be a part of a valley. Okay, and we know for sure that this is not a valley because then it would have been the case of 3. So this has to go below this line or on this line. So if it's on this line, then that's the best case scenario. We don't have to consider it right now. If it goes down like this, then we don't go down this line. This line is the limit of where we can go. And if we go till here, I think we have deleted the mountain that was there. Okay, it's not a mountain anymore. But now we have deleted this valley. Like we haven't deleted this valley yet. We still have this valley. This valley would be deleted if this was higher than this. Okay, yeah. So kind of like these are the conditions. It has just too many conditions. I mean, I wonder how many submissions are there right now. This is too much casework for a B problem. Just 200 submissions in what I think it was almost 30 minutes, 24 minutes, and just 2 submissions. So I think this was really difficult according to a B. Let's try to implement it though. Still not sure how to exactly implement this, but we'll think it up as we go. Okay, so we have the input. Now I think we just have to see for each element if we change this one, then how will the answer get affected? Okay. I think first of all, let's try to calculate the answer for the unchanged array. Okay. Hmm. Okay, so yeah, I think I've overcomplicated it. I'll explain the easier solution now. So, okay, anyway. So we had like the answer is okay, we will start from 1 real and minus 1. Okay. So if AI is greater than AI minus 1 and it is also greater than AI plus 1. Okay. In this case, our answer will increase by 1. Similarly, if it is smaller than both, then also the answer will increase by 1. Mm, okay. In both cases, our answer will increase by 1. Then let's try to see how much answer will change finally by doing some changes. Okay. So, like in all the cases that we talked about, whether there are two or three or whatever, one common thing was we were always making two consecutive elements equal, right? We were like in this case as well, we were either doing this or we were doing this. So here we knew what we have to do, but in other cases it wasn't so obvious. Like in this case, we don't know whether to do this or to do this, or even both of them are advantageous or not. But yeah, that's what we were doing. So we were always making two adjacent elements equal. So yeah, let's try to do that only. For each element, we have to either make it equal to the previous one or to the next one. Okay. So we'll try changing each of the elements and we'll either make it equal to the previous one or the next. Okay. So also, I maybe think that we don't really need to change the first or the last elements, but I'm not sure. So I risk it. Okay. So if okay, so maybe we can just consider the first and the last separately. So like first and last we'll consider separately. Okay. Yeah, and let's try everything else. So we have two options here. So either make this equal to AI minus 1, okay, or equal to AI plus 1. So yeah, these are the only two options that we can do. So we either make it equal to the AI minus 1 or AI plus 1. Okay. So if we make it AI minus 1, how will the answer affect? How will the answer be changed? Hmm. So we know that it is a part of three values, I think. Sorry, three elements. The ones centered at I minus 1, I, and I plus 1. Okay. So now if these two are equal, let's try to see how much the answer changes for both of them. Let's say in temp equal to 0. Okay. Now if hmm, hmm, okay, too much casework. Okay, so So if there was a valley or hill at this current point, then definitely it will be removed and answer will be increased by 1. Apart from that, if there was a hill or valley on the uh, point at centered at I minus 1, then also will be okay. If I minus 1 is actually greater than 0, then we can copy this here, and I think we can just decrease I by 1 for this purpose, and once it's done, just increase it back. Okay, right, and okay, so these two will definitely be decreased. Wait a minute. Okay, so yeah, so now we just have to see how the point at I plus 1 is affected. Okay, so if I plus 1 is smaller than n minus 1, okay, okay, the next element is not the last element, then it can be like a center. Okay, so if that's a center, then we have to check whether um, like we have to check two things. First of all, whether there was already a hill or valley there or not, and whether there is still a hill or valley there or not. So you can check the already place easily, like uh, just change I, and yeah, so okay, so that one was easy, but now we have to check if there's still a valley or hill at that place or not. I think even in this case we will have the same thing. So we will put temp equal to 0, and we'll have the same thing here. Okay, kind of. Okay, but we have to like if there's still a valley or a hill at this point, at the point I plus 1, then we have to consider it, like we still have to consider it, or if we have created a new hill or valley, then we have to consider it. Okay, but temp is like the thing of storing in temp is actually the number of hills or valleys that are decreased. Okay, so here I have to check if any hill or valley was increased at that point. Okay, so we know that the okay, so int x, let's say a variable x, and let's call it ai minus 1. So we know that ai became x. Okay, I think now we can just copy it again. We can pull it upwards a little to make it less confusing. We can just write here x equal to ai plus 1, I think. Okay. Like x is the change element. Okay, so we're back here. Now yeah, so just I'll just copy paste this thing again. And this time I have to decrease temp if there's a value or hill here. So the thing that will change is AI minus 1 will actually become X. Yeah, so yeah, that's the difference because we changed the element. So we'll do kind of the same thing here, just that when we copy paste this, we have to decrease the temp instead of increasing it. So yeah, we know that already. But this value has to become X instead of uh, yeah. Okay, so I think that's done. Now we just have to say answer is the minimum of answer minus temp, because temp is something that we've decreased in this step. So we can just print answer in the end and leave a new line. Now one thing that's left is doing the first and last separately. So I'm willing to waste some time to figure out if it is not required. So can we always solve the problem without actually changing the first and the last? Mm, like, is it always possible to not change the first element and still get the correct answer? Hmm. We know that there's no hill or valley center at this point. Okay. So we have no hills or valleys center at this point. I'm talking about the first point. Then this is the second point, right? If we're changing this, we can only change the hill or valley on the second point, because cannot affect the third one. Okay. So what we're doing here is we're just I think increasing this up till this point to kind of make them equal. I think. No, wait a minute. Yeah, yeah. Okay. So we make them equal, and this way we will get rid of this hill. Okay. So I'm trying to claim that, I'm trying to prove that we can always get this like a same or the better answer by making this equal to one of these. Okay. So one thing is, if we do this, okay, then the answer will definitely decrease by at max 1, because this is not affecting more than one hills or valleys. So the answer won't be changed by 2. So if this is the best answer, then anywhere if we can find 1, then that's also the best answer. So let's try to find the answer equal to 1 here. Okay. So this is the next element, and if we make it equal to this, like, we don't even care if this is smaller or bigger than this. I'll just make this equal to this, and we decrease the answer by 1, because it became something like this. It became something like this, and we know that this is neither a hill nor a valley, and even this can't form any hill or valley. So yeah, we don't have to check the first and last separately. So actually, no need, and we solved the answer already. So this should be the answer. Otherwise, I'll bang my head on the wall. Okay, so I was joking about banging my head on the wall. Mm, hmm. Okay, this is too less than what I expected. It bothers me a bit. Okay. Hmm. Okay, so I found one mistake. Yes, but I don't think that will matter much. Okay, it made it worse. Hmm. Okay, sorry. Okay, got it. Okay. Mm, okay, so best is the minimum of best comma answer. We don't have to actually change the answer, and we just print the best. Okay, so it's still a bit wrong. Mm, specifically this case. Hmm. I see a hill here, and they're saying there's no way to eliminate this. Yeah, I can eliminate this one. I can make this equal to 2. But then there will be another hill. Okay. Yeah. Hmm. So we have a hill here, then a valley here, then another hill, then another valley. Okay. We have a lots of hills and valleys. And yeah, it seems a bit obvious that we um, cannot decrease or we cannot delete all of these. I'm not sure why my code says that we can do so. Hmm. Okay, so let's do this one separately. Okay. So first of all, let's print the answer and see if that is calculated correctly or not. Answer is 4. So I think this is one hill, then one valley, then another hill and another valley. Okay. So the answer is 4. That's correct. Okay. Then I think we should just print all of the values of temp. Okay. Along with I think that should be good. Yeah, this looks good to me. I think. Mm, okay. So if answer was 4 and we never got temp equal to 4, then how is it equal to, how does best become 0? Hmm. Oh, sorry. Best is equal to answer. Okay. Yeah, okay. Now it's correct. We just comment these two out. So either I'm doing really bad or this is really tough for a division 2. Okay. Okay, so I think I'm doing really bad because there are already 900 submissions here. So let's still try to cover this up, although now it looks really difficult. We have given 3 bags. Each bag contains a non-empty subset of multiset of numbers. Hmm. 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 What? Okay. We pick 2 bags. I think we pick 2 numbers from the 2 bags, subtract the second number from the first, and remove the second. Okay. Okay, so if there are multiple occurrences, we'll just tamper one of them. Hmm. Okay, so we have Okay, three bags. What do we have to do? Okay, 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 okay. Wow, so we have to print the maximum number that's left. So what we're doing is, I think, we're subtracting these one by one. And wait a minute. Okay, yeah, obviously it can be always done. I don't think we need to have this as a positive number. Yeah, so this one looks a little bit easy, I think. So actually we have like three bags, right? And we have elements like this. So what we can do is we can pick one element from here, one element from here. Then we subtract these two. Sorry. Then we subtract these two, put them here. So this one becomes a minus b, and okay, it's not easy, but I think I at least understood the question. And this one gets removed. So what happens? So like one way to like to prove why we can always do this is like you have some elements like this. So let's just pick any one element and let's call this the final element. So we don't have to remove this and we have to remove everything else. So just pick these two and subtract it from any of these. So like these two will get erased, and maybe these will change. Okay. After that, just subtract all of the elements from the other baskets to this one. So then we will have only the final element left and everything will be empty. Okay, so that's how we can prove that it's always possible to do it. And we didn't need to prove it because it was written in the question, but I still did it for more clarity. Okay. Now we want the maximum element and that we can get by doing something like this. So if we combine all the elements, and doesn't matter from which bag it comes, combine all the elements and write it somewhere. The final answer will be like plus minus a, plus minus b, plus minus c, plus minus c, and so on. Like all the element will be either added or subtracted from the final answer. So we want the bigger elements to be added and the smaller to be subtracted. Although it's probably not greedy, but because it's definitely not greedy because like if we subtract b once, then we can add it in the next step. Okay. So I think we can always add all the elements of one back to the answer, because like let's say all of these elements belong to this bag and this is the final element. Okay. So what we will do is we will just subtract all of these here. Okay. Let's say we subtract all of them to just a single element. Okay. So if this was like k, it becomes k minus a minus b. And then when we subtract this from here, we get a plus b plus c minus k. So we can get at least all the elements of one bag with positive sign. So yeah, that looks like a good thing. Apart from that, if we move all of these elements from this bag to this bag, then we can maybe get positive sign on all of these elements as well, right? Okay, yeah. So I think I kind of get it. Whenever an element moves from one bag to the other, its sign changes. So let's say this is the final bag. So the elements that actually stay in the final bag doesn't matter. Uh, okay, no. So it depends on the path. It's not a conservative thing. Like we can always get to have them with a positive sign because we can send them somewhere and then immediately bring them back. So they'll have the positive sign. But about the other elements, I can't really say that because like we can get one of the bags as completely positive because we can just first move all of these elements to this bag and then when we move it back to the original, back to the final bag, like all of these first became negative and then became positive. But what will happen is all of these elements will become negative. Okay. So maybe what we can do is we can just first transfer all the elements to this bag. Okay. Then when we put this into this bag, like we emptied this. Okay, so we can't really empty this because we need at least one element remaining here. So like put we take out all the elements and subtract them here. So all except one. Okay. So this element will be like A minus B minus C minus D and so on. When we put this one here, it becomes A plus B plus C plus D and so on minus K. Okay. Now we have all elements in this bucket positive. And if we go this route, we can have we can like preserve the signs, and this will be negative, but and one more element from here will be negative. So like the smallest two elements from this bucket will be negative, and everything else will be positive. Can we do better than that? Hmm. Okay. Here maybe we can add all of these elements. What's the sum of all the elements? It is 10 plus 20, 23, and 26. Is it 26? Okay, so I think we can get the positive sign for all of these elements and the negative sign for just these two. Yeah, so yeah, I think that's what we're getting in this case, but it could be a coincidence. So 549718. I think it will be sum of these minus 8 maybe. 12, 4, 16, 2, 18, and 27. 27 minus 8, 19. So is the answer 19? No, it's 29. So we're way off. Hmm, maybe we can just always Leave the smallest two elements no matter what. Let's try to leave this one in it and this two. It will be like 7, 5, 12, 4, 16, 16 and 9, 25, 25 minus 3 is like 22 and 7, 29. So from looking at the examples, it seems like we can just always leave two elements. Hmm, get everything else as positive. So can we actually do that? Like leave these two elements and get everything else positive? So if both the elements are from the same bucket, we can obviously do that. We have already proven it. And if we can also do that for two elements from different buckets, and if we can prove it, then we're done. Then it's always possible. So can we get the negative sign on two elements from different buckets and positive sign on everything else? Okay. So one thing as a starter could be, if we want one negative here and one negative here, we will always choose this one as the final bucket. Okay, because that's my choice. So that's how I'll start. And let's say I want this one negative. So maybe first of all, I send all except one from here to this element. This becomes k minus a minus b minus c and so on. Okay. Okay, yeah. So yeah, this doesn't make anything wrong, because then I can say that this bucket had only one element. This element has to be negative. Okay, and one element from here has to be negative. So is it possible to achieve this? I think it is possible, because what we can do is, like, we can take all of these elements and subtract them from this, and then take all of these elements, subtract them from this. Then we put this here, so everything becomes positive except this element, and everything becomes positive from here except this element. So yeah, okay, so like consider all of the elements, then just leave two elements, and apart from those two, everything can be positive and those two will be negative. So yeah, we just have to sort them together, I think. Okay, and we always have at least three elements, so that's fine. Okay, so let's have a variable n, temporary variable x, I think. Okay, let's just we don't even want them separately, we can just add them. Okay, n should be 0. Okay, now I need a vector of n elements, and I'll just input everything. Okay, now just sort the vector. Okay, I wanted the sum, so let's keep a track of the sum. Okay, then just subtract the smallest two elements. So sum minus equals a0 plus a1 multiplied by 2, because we added it once in the sum, so we have to subtract it twice. And that's it, I think. Do we have only a single test case? Okay, so I think we've done it already. I think a lot of people could have guessed this one. Like, there wasn't even any need to prove this, because it seems kind of obvious from these cases that we can always leave the smallest two elements out. Okay. Okay, so I think we were wrong. Wow. Okay. Mm, maybe there's a special case in which we can get only a single element negative. Yeah, okay. So I think there's a special case when we can have only a single element negative. So that's when, like, if we have three buckets and one bucket has only one element. So what we can do is we can just say, like, this is the final bucket. Mm, so we move all of these elements to this element first. Sorry. So all of these elements we move to this. Then all of these elements also we move to this. We bring this back. Yeah, that's an exception. If a bucket has a single element, oh no, I messed it up. Okay. Have I gone a little dumber, or like these are? I think these are really tough. Hmm, no way to know. No way to know. Okay. Now we do this for the rest. And two and three. Hmm, okay. Okay. I still want the sum and separate vector. I'll be like v dot pushback ai. Oh, sorry. Mm, v dot pushback bi and ci. Okay. Then the sum, I have to get the sum of all the elements in v. Okay. I have the sum now, and I have to sort v. Okay. So answer is equal to sum minus v0 minus v1, the double of this. Okay. So this is the answer if we make two elements negative. But the answer we can have a better answer if we make only one element negative. So it is like if n1 is 1, okay, then the answer could be sum minus just 2 into a0. Okay. Instead of making two elements negative, we can choose to make only a single element negative. Okay. Okay. Now if n2 is 1, we need a single element from b negative. Finally, if n3 is 1, make a single element from c negative. And that's our answer. Okay. So this time it should be correct, and I was wrong. It could not have been guessed easily. Okay. 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 So we're still wrong here. I think at least that was correct, that we can get exactly two elements to be negative. Hmm. 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 Okay. Okay. So if we have like 999, 999, and a 1, Getting 53. Okay, we just got this one negative and everything else positive. So maybe what we did is we subtracted all of these nines to this one, then it became 1 minus everything else. When we subtract this to this 9, then it becomes everything else plus this 9 minus 1. So that's 53. So that seems like a best case kind of thing. Hmm. Hmm. Otherwise, we can always get exactly two elements to be negative. For that, what we will do is take all of the, like, let's say we want two negative elements in this one and this one. So this is the final bucket, and apart from the negative element, everything else will be subtracted to this element, and everything else will be subtracted to this element. Then we subtract this here and this here. So yeah, we get two negative elements and everything positive. Okay, if they're from the different array. If they're from the same array, then what we can do is, let's say we want to get these two negative and everything else positive. So what we can do is, okay, pretty sure we can do this because that's what we did in the first case. I think I even proved this, that we can leave two elements from one bucket out for the first time. Like, that was the first thing that we proved. Let's see. Okay. Um, hmm. Did we have to choose the numbers from? Okay, we can choose two non-empty bags, and they cannot be the same, I think. Okay. Hmm. Let's send all of these elements except one to this element, and it's fine because this had to be negative anyway. Now this has a single element. Then hmm, hmm, not sure if it is actually possible to always do it. Okay, so we have three buckets, and let's say we want to get two elements from this bucket as the smallest elements. Okay, so both of these are like the smallest elements, and we want to get both of them negative and everything else positive. Let's keep them separately. Okay. We have two elements that we want as negative. So in the first step, what we can do is we can just remove everything from here. Okay. Mm, okay, maybe we can't do that because it's positive, right? Can we actually get two elements from a single bucket negative? Should I watch my video, because I think I should stop this video and watch it, because I think I proved it earlier and now I think it's not possible. Anyway, so I want these two negative and everything else positive. Okay. I think I can remove everything from here and subtract it from this, because then this will become negative, all this will become positive, and all this will also become positive. Okay. So we have, like, without the loss of generality, we have two elements in two buckets, and we want these both of these to be positive. Then mm, we have these two elements, we want them to be negative, and everything else we want to be positive. Okay. Hmm. Is it really possible? Wait, how did it happen in this case? Mhm. Yeah, we did it in this case. Okay, so what do we do? So we want all of these elements to be positive, right? I'll be honest, this doesn't seem possible, but it probably is. So okay, so let's do some hit and try. Let's do it here and do this here. Okay, so this is A, this is B, this is going B minus A, this is A minus B. Okay, we have two elements here and we want this one to be negative. Hmm. Okay, we have two here and like a lot here. Since we want this to be negative, then we can just subtract all of this, add it here. So I'll call it everything else. Okay. Hmm. Wow. I think the exception is if we have like one and something else. Okay, like uh, from among the n1, n2, and n3, if at least two are one, if n1 and n2 are equal to one, then I think there's a problem. I think we can't have two elements from n3 equal as negative. Then at least one of them should be greater than one, because it doesn't seem possible in this case. Like we had three buckets, okay? We have one element here and like a lot of elements here, and we have two of them negative. Hmm. 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 I don't think we can do that because the first move has to be attach one of these elements somewhere here, right? So if this is like B and this is if this is K and this is A, so this becomes K minus A, and then we seems like we don't have any other option but to send this back here, because the thing is K is positive, so we cannot attach it with any positive number. Mm, we have to attach it to a negative thing. That will become, if we bring it here, it becomes A plus B minus K. Now the problem we have left is we have one bucket with a single element, another bucket with a lot of elements, and we want one of them to be negative, everything else to be positive. Okay? I don't think this is possible. We really can't do that. Hmm. Is it possible? Because our only two options are either we send this one here or we send all of these here. Okay. And since these have to be positive and these have to be positive, no point in attaching them because then it will be impossible. So the only move that we have left is to send this here. Okay. And this has to be negative, right? So if we send this here, this becomes positive. Sorry, then we just lose this element and we want everything positive now. So that's impossible. Okay, so the counter case is, I think, one of the weirdest counter case. Like if n1, wait, two of them are one, right? So if n1 is one and n2 is also one. Okay, then we cannot get two elements negative, so we have to get one negative from these. Okay, so we have to do one of these and we don't have any other option. Okay, similarly, um, hmm, okay, similarly, if n2 and n3 are 1, then subtract 1 from b or c, and if n3 and n1 are 1, then do one of these. Okay, hmm. I could have pulled this one up. Okay, I didn't need these, right? So we could have just done something like pull these up, right? And here we write a max. Okay, yeah, yeah, this looks fine. Now the condition on using this is at least two of n1, n2, and n3 should be greater than 1. So we can, hmm, okay, that's the condition that we want. So if we have like 5, 1, 1, and we have a 1, 1, 10, 10, 10 here, and like 5 and 5 here, then the answer should be everything minus 5. That is 32 plus 5 minus 5. Okay. So I think now it must be correct. If it is not correct, then I'll just skip this one and my God. Okay. Hmm. Very beautiful. Hmm. 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 Okay. We have one and a big number. And there's no point of getting two elements negative because if they're from the same bucket, then it's not possible. And if they're wait a minute, what if they were from the what if like wait a minute, what if we had like two elements here? Okay, we want these two to be negative. Okay, let's say first we attach this to this, then maybe this. Hmm, okay, so this has to be positive, and just this has to be negative. Hmm. What if we attach this back here? And that's totally fine. Okay. Hmm. I think it's still not possible to actually do it. Hmm. 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 Right. I don't really get what could be the first step because this step is pretty much pointless. What about this step then when this is pointless? This is also wrong. Hmm. Hmm. This is definitely wrong. So the thing is, like if we have these here, we want all of them positive. So we'll never merge two positives because then one will be positive and one will be negative. We have to merge a positive with a negative, right? So the first step will obviously be merge a positive with a negative. So we can either do this or this or this or this. Okay. If we do this, then I think it's wrong because then both of them will have the same sign, right? No, no, no. Okay, okay, okay. Okay. This is correct. Hmm. But it's not really correct. Hmm. Hmm. I say we remove this one from here first. It can only go here, right? So I think, wait a minute, just let me look at the sample because it was something like that only. Hmm. So what was the first step? Hmm. Interesting. Okay, so there's definitely something that I missed. That's like if there are only two elements here, and nothing else. So what doesn't matter if these have only one. What we can do is we want to get both of these negative and both of these positive. Maybe just merge them. Okay, and then here and here. Am I done? Hmm. Yeah, we're done. Can we never pick two elements from the same bucket and hope that it works no matter how many elements are there? So, like, let's say this bucket had like a lot of elements. This also had a lot, and this also had a lot, but we wanted these two to be negative. Can we do it? You have plus everywhere, plus everywhere. These two are minus and plus everywhere. Okay. Yeah, actually, it's impossible because we must merge this to a minus. Okay. So we need a minus somewhere here, like at least either in this bucket or in this bucket. We must have a minus in the two buckets. To have a minus there, what can we do? So to perform operation between these two buckets, we need to have a minus in these. Okay. So like we just have to make a minus using this operation. Not really possible because yeah, these are useless steps. We can get either we can. Hmm, I think it's like either we can take two elements from two different buckets or just take an entire bucket as negative? Yeah, I think that's it. Either take two elements from two different buckets or take an entire bucket. This contest has gone already way beyond bad, and there's not much I can do right now. But for now, let's just try to not give up too soon, maybe. Okay. Mm, why am I making so many silly mistakes today? Mm, okay. So the answer is like either I think I have to sort all three. Sort all A, B, and C. Okay. So let's say the answer is 0. It can be mm, some minus twice bucket I. Okay. So that is leaving an entire bucket out. The other thing could be leave two elements from two different buckets out. Okay. So we can leave out like A0 and B0. Okay. Or B0 and C0 or A0 and C0. Yeah, so I hope this is correct this time. And if it is not correct this time, I'm definitely leaving it. Actually, let's just leave it already. Doesn't matter if it's right or wrong. Okay. So there are n cells numbered from 1 to n left to right. You have to place robot and then must make exactly k moves. Okay. Let's see how many submissions for which. Oh, so we actually managed to do this. Phew. Okay, so we have half an hour. Maybe we can do D. I'm not sure though. Okay. With D sum of parts. There are n cells numbered 1 to n from left to right. Robot has to make k moves exactly. In one move, the robot must move one cell to the left or right. Mm-hmm. Okay. Mm, can we revisit the same point twice? Okay, okay. Sum of values over all possible good paths. Okay. So, uh, can it start anywhere? Mm, mm, okay, yeah. Okay, yeah. Okay, so it can start anywhere. Wow, okay. So it can start anywhere and then go anywhere from there. Wow, this looks very tricky actually. So, so it's like we have given something like this and hmm, so like the robot can start anywhere, then go like any go about any path like this. Okay. And I think we have to just count how many times each cell is visited. Right. So is K small or anything? Okay, so both N and K are like bit small. Okay, wow. We even have to process some queries. I was actually not able to solve it for a single query, but okay, so I think queries shouldn't be too tough. Mm, we just have to calculate the coefficient for each value. Yeah, calculate how many times will this be visited. Okay. Yeah, so instead of calculating how many times will this be visited, we can calculate something like fn comma k. So how many times? Sorry, fid comma rem. Okay. So this means that this position is id, and we have rem moves remaining. Okay. So how many times can we visit this such that like this? Okay. So initially, it's like f of id comma k equals 1. So that goes for everyone. I think that's it. So we just have to calculate some kind of a dp. F of id comma k is 1 for everything. And then, yeah, so f of id comma rem depends on f of either id minus 1 comma rem plus 1 or f of id plus 1 comma rem plus 1. And that's it. So this way we can calculate the coefficients for everything. Wow, so this was so much easier than the C problem, at least for me. Okay, so let's say int dp n cross n Okay, int nkq. And so now we have the coefficient. Hmm. Okay, right. So now we have the coefficients, and finally we'll solve the query later. For now, so, okay, so these are the, I think, scores or something. These are the values. Okay. Anyway, so we need the coefficient. Okay? And how many times each vertex is there. Okay, so int id comma rem, as I said. What is the mod? Okay, 10 to the power 9 plus 7. Okay. So if rem is equal to k, okay. So if rem is equal to k, then we can just say return 1. So for everything, it is 1. We're starting the path here. Okay. Otherwise, if so if wait a minute, if id is smaller than 0 or id is greater equal to n in both cases, then the answer is 0. Fine. Wait a minute, this should come first. Yeah, okay. So if id is valid and rem is equal to k, then is 1. Otherwise, the answer is dp of id comma rem. Okay. Now, if it is already calculated, just return the answer. But if it is not calculated, it is equal to id plus 1 comma rem plus 1 plus uh, minus 1 comma m plus 1. Okay, mod m. Okay, so this way I got all the coefficients. Let's just remove this so it's a bit faster. Okay, then I'll just return the answer. Fine, so now I have all the coefficients, and let's say the final answer is 0. For int wait a minute. So we haven't actually calculated the coefficients, we have just calculated this dp. The coefficient will be like the sum of everything for each id. Okay, so for j from 0 to k, let's say coefficient of I, that will be equal to, sorry, to that we will add this dpij, sorry, cal c I j. Okay, yeah, seems right to me. So we have all the coefficients. Now let's say we have the coefficient for I. We can say answer plus equal to the coefficient of I multi, oh sorry, I have to use the mod operations. Almost forgot that. Okay, so okay, answer equal to answer plus the coefficient of I into 1 long into a of I mod m. Cool. So we have the answer if nothing is changed, right? Now we have to make some small changes and print the answers for each query, or only the queries, right? Okay. So we have two queries. In one query we input I and x. Uh, in one query, we will input I and X. Okay. So we will change the value of AI, right? First of all, just let's remove AI from the answer. We will do answer. Let's write it as comment first. Okay? We will do answer equal to answer minus coefficient of I into AI. Okay. Then we will add coefficient of I into X. Okay. So we will do something like this. So we can just directly say the difference is equal to X minus AI, right? Plus M mod M. So that's the difference. And then we can say, did I use mod operations here? Okay, I did use them. So then we can say that answer equal to answer plus the coefficient of I into 1 long into the difference mod M. After that, we can just change AI, make it equal to X. And we also have to print the answer and leave a new line. I hope we've done this because I don't really have much time left to debug it if it's wrong. This is just okay. Compilation errors are actually easy to fix because the compiler tells you the error. Okay. Oh my god. Oh shit. This is wrong. Hmm. So I don't know what to do now because I really don't have any idea. Hmm. I don't even have the time to debug this. The answer is always a little less than what it should be. This is an infinite loop. I think this run. We can. Hmm. Hmm. This seems so right that oh, hard to believe it's not working. Oh no. Okay, so the indices are actually zero based, not one based. So I was still wrong. Wow, okay. We're still wrong, right? Are we more wrong now? Hmm. 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 I think I can debug this a little by printing the machine value. So one should be in two parts. That's correct. Two should be four times, not three times. So this is wrong. Hmm. 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 Oh, okay. Did something wrong. Um, I think maybe we can fix this by changing a little bit. If ID, uh, if ID equal to 0 or ID equal to n minus 1, then we return 1. Otherwise, we return 2. Maybe we can fix it this way. Hmm, but it's still wrong, I think. Uh, uh, hmm. Make it like the number of parts. Okay. The number of parts such that let's start with mm, so maybe I'm counting the number of parts correctly, but I'm not counting how we reach there correctly. God, oh, such a brick. Wow, okay. Oh, it ran finally. Anyway, so okay, so I think shutting up helps a lot. So I wasn't able to figure out what was going wrong, but then I decided to shut up for a little, and I think I think within just I think just within a minute I figured out what was wrong and I even fixed it, even though I was clueless while I was speaking. So yeah, and I don't think mm, I don't think these screencasts are like very accurate because um like I cannot emulate an actual contest like this because when I'm speaking I cannot think that efficiently. So like the moment I decided to shut up, I made this small change, which kind of changes the entire idea of the solution, and it helped me pass it. So okay, so now I'm gonna explain this one, explain how it works in brief, like in a little detail. So like not too much detail, but not just get it. Anyway, so we had this array something like this, and we could go from here to any of these or something like that. So I said the state would be like dp of id, comma rem, and rem are the number of remaining moves. Okay, so um, so it's something like if you start here and like sorry, so this is 0 1 2 2 comma let's say 10. Okay, so it's like you start here and you have 10 moves. So how many paths, like I'm trying to count how many paths are there such that if you start from here and you have 10 moves, so you can do it. So like one path could be something like this, and like you have to just count all the paths. Okay, so count of paths starting from this state till end. Okay, so how can we use this? um the cool thing to notice here is like if you start from here 2 comma 10, let's say, so you have like 10 moves and you go somewhere. So those are the number of paths. Okay, and let's say k equals 20. Okay, now we want to know or let's say k equals 15. Okay, so now we want to know like if we start from any x comma 15, right, and x could be anything. So if we start from x comma 15, I want to know how many paths will lead me to this point, to 2 comma 10. So it's actually like we can retrace the steps back and look it in the reverse direction. So it will be like the answer will be equal to 2 comma 15 minus 10, because like from whichever x we start we do 5 moves and finally reach here. And here what we're doing is we start from here, do 5 moves and reach somewhere, and we can just name that somewhere equal to x. So this will count the number of moves that are required to reach from some starting point till here. So um, if we're at I comma j right now, then it takes dpij to reach a terminating point, and it takes dpi k minus j to reach here from the starting point. So these are the two things that I calculated. Now what I will do is I will just multiply both of them, dpij multiplied by dpi k minus j. So it will actually count all of the paths in which I was at j position, because you start somewhere, you first reach till I, the j position, and then at the kth position you finally reach anywhere. Okay, so if we multiply both of these things we get this. Okay, and these many times uh, like AI will be added to the answer. Okay, so it was something like this. So these many times AI will be added to the answer. So what we want to do is we want to perform a summation of this overall j. Okay, so we want to perform a summation of this overall j and say that this is equal to coefficient of I. Okay, and the answer is equal to summation of I equal to 0 till n minus 1. Okay, and here we put AI into coefficient of I. Okay. So we just have to calculate this now. Only this part is left, and we have some queries here, so we are changing this and so on. So that's actually very easy and it's trivial. So I won't explain that. So yeah, that was the main thing that we had to do here. And I was doing something terribly wrong. I didn't have this part, and I was solving it in, I don't know how I was still solving it. But then when I decided to shut up, I realized that this is necessary, and I put this here. So that's how I got an accepted, a pretest passed actually. And I have no idea what's my rank. It must be at least 1000 maybe. Okay, 300. So actually that's not bad. And we beat the young champion, Everrule. Although he did the tougher questions. I think he probably decided to not do these. Anyway, so yeah, it wasn't good, but I think I think it was really hard. Maybe I'm just getting rusty or something, but I really think like this contest was very hard. So anyway, I'll solve E later. Maybe I'll stream the solving of E. So look forward to that. And as I said, there are a few links in the description about my Discord server and the poll in which you can vote about this uh, this Hindi video that I'll be doing on an academy. Okay, so thank you for watching.